In example number 12, we want to be able to write a rational function from intercepts and asymptotes. The definition states that writing rational functions from intercepts and asymptotes. If a rational function has x-intercepts at x equals x1, x2, all the way to xn, vertical asymptotes at x equals v1 all the way to vm, and no x equals any Okay, in example number 12, the definition that we need to look at here is that writing rational functions from intercepts and asymptotes. If a rational function has x-intercepts at the following x values and then vertical asymptotes at the following x values, where the x-intercepts and the vertical asymptotes are not equal to each other, then the function can be written in the following form. F of x is equal to a. You have your numerator where your x-intercepts are located, and in your denominator you have your vertical asymptotes, where the powers p or q on each factor can be determined by the behavior of the graph at the corresponding intercept or asymptote, and the stretch factor of a can be determined given a value of the function other than the x-intercept or the horizontal asymptote if it is non-zero. So how do we go about this? Well, given a graph of a rational function, we're going to write the function by doing the following three steps. Number one, you're going to determine the factors of the numerator. You're going to examine the behavior of the graph at the x-intercepts to determine the zeros and their multiplicities. This is easy to do when finding the simplest function with small multiplicities, such as 1 or 3, but may be difficult for larger multiplicities, such as 5 or 7, for example. Step 2, we're going to determine the factors of the denominator. We're going to examine the behavior on both sides of each vertical asymptote to determine the factors and their powers. And number 3, we're going to use any clear point on the graph to find the stretch factor. So we're going to write the equation for the rational function shown below. So the first thing we want to do is maybe point out, any intercepts, any x and y intercepts. Well, where does it cross the x-axis? Well, we can see here it's crossing the x-axis at -2, and it's crossing the x-axis at 3. And then we also look at the y-intercept, and we can see that there's a y-intercept at -2. Now, I do want you to notice here that we have this graph is going downward in these areas. It's going up in that scenario, and then it's going towards positive and negative infinity over here. So the graph appears to have x-intercepts at -2 and 3. At both, the graph passes through the intercept, suggesting linear factors. The graph has two vertical asymptotes. The one at x equals -1 seems to exhibit the basic behavior similar to 1 over x, with the graph heading towards positive infinity on one side and heading towards negative infinity on the other. The asymptote at x equals 2 is exhibiting a behavior similar to 1 over x squared, with the graph leading toward negative infinity on both sides of the asymptote. So here we can take a look at this. So here we have our two vertical asymptotes. One of them is at -1, the other one is at 2. We have our two x-intercepts at -2 and 3, and we also have our y-intercept at 2, or -2. So we can use this function to write a function of the form. We have f of x, which is equal to a, times x plus 2 times x minus 3, because those are the x-intercepts. And then in the denominator, we have our two vertical asymptotes. One of them is -1 and the other one is +2. And since we know that we have this form here, it's going to be squared because of the fact that we have two vertical asymptotes and it's below, and the middle part is below the x-axis. Now, to find the stretch factor, we can use another clear point on the graph, such as the y-intercept. So we're going to need that y-intercept, which is 0, -2, to figure out the value of a. So f of x is going to be -2, and we're going to plug in 0 for x. We plug in 0 for x, we get -2 is equal to a times -6/4. And then if we multiply by the reciprocal, we're going to get -8/6, and therefore a is going to equal 4/3. And this gives us a final function of f of x, which is equal to 4 times x plus 2 times x minus 3 over 3 times x plus 1 times x minus 2 squared.